All right. Well, it is 2:30 UTC, and here's the late edition of Astronomy Daily Live. So welcome everybody. Howdy, howdy. Come on in. Come on in. Gonna sit here for a little while. Probably not actually a full hour. This might be a little shorter live stream because of the late start. But come on in, join the ever-growing crowd and circle of friends to just sit around for a while and think and talk all things astronomical for, just a little while every single day. So yeah, welcome. Come on in. Come on in. So on the panel again, we've got Tom. Hey there, Tom.
Hey, Cosmic. How's it going?
Everything's well. Yeah, the late start was primarily caused by a surprise storm here that blinked our power a few times, and so I'm sort of like, well, let's let this storm sort of pass and or dissipate first. So gave it 30 minutes, and yeah, it's pretty much a goner at this point. So yeah, I don't think the chances of losing power now here are I would say pretty close to zero. So yeah, except for that, all is well. So also in the panel we've got Bobby. Hey there, Bobby.
Hey, what's up?
Everything going well over there?
Yep, all is well, and
cool.
Well, my church is going to do some relief efforts in Florida, so we have like a shorter church meeting. It's going to be like today, like earlier today, and next week they're going to have shorter church weeks.
Oh, nice. Very cool. Well, right before the live stream, we sort of have a pre-show of sorts, and Tom was talking about these. Well, the guy or the person that was talking to the Weekly Space Hangout this week was from JWST, and he was talking about some kind of solid state gyro. What is that?
Well, I don't really know. The guy's name was Paul Geithner, and he's one of the deputy planner or something, manager for JWST, and he said that the gyroscopes on the JWST are different than the ones they used with Hubble and Chandra and the other telescopes, and that these are now solid state gyroscopes, which means there's no moving parts. And he didn't go into too much detail about what they were. I did a little bit of digging, and what I found was some discussion about the gyroscopes that said it uses a vibrating structure to determine the rate of rotation. So it's some kind of crystal, gets a vibration going through it that you can figure out what the rate of rotation is and use that to determine your position in space.
Interesting. So, but I mean, they're still going to have then reaction wheels, right, in order to move the thing.
Yeah. He said they did talk about that a little bit, and the reaction wheels are pretty much the same that are on the other space telescopes. So those, they could still run into problems, but.
Gotcha. Yeah,
So we probably might see a longer life with the JWST than any other telescope, huh?
Maybe, yeah. No moving parts. That is definitely sort of a recipe for a longer life. So yeah, you know, if you haven't seen Christian Reddy's um, uh, 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 YouTube channel, he did a segment on the HST's reaction control system. You know, the reaction control wheels, the gyros. There's also these magnetic bars and all that. He did an absolutely fantastic description of those systems over on his YouTube channel, which
Is
is
that like still on life support?
they're I think right now they're trying to figure out, you know, what exactly the status of things are. Not exactly sure precisely what's going on at the moment, but as far as I know, yeah, it's still in some kind of um, you know, stand down thing. I think, you know, they're not doing any kind of observations or anything like that. But yeah, I'm trying to remember Christian Reddy's YouTube channel. What's the name of
Launchpad
that thing?
astronomy?
Um, Launchpad Astronomy. Thank you, Bobby. Yeah, yeah. So definitely check that out, and subscribe, of course, to his YouTube channel also. Christian is awesome. Um, knows his stuff and does really nice segments on, you know, lots of astronomical things. So he was extremely thorough, it seems, in his description of the various systems, and yeah, I definitely learned, you know, what the difference is between a reaction wheel and a gyroscope, right? The gyroscope is sort of the sensor, right? That senses sort of the configuration, and the reaction wheels are the things that actually move it. So yeah, cool. You know, got to admit that there are many things that I just don't know, and that was one of them. um, but now I think it seems as though, you know, might have a handle on that a little bit. So yeah, so now to hear about this concept of a solid state gyro, and that is some kind of a device that acts like a sensor, you know, to tell which way things are pointing. Yeah, that's kind of interesting. You know, it doesn't surprise me, right, that there are those kinds of advances. You know, we humans can do some pretty amazing things if we want to, and I think, you know, there is definitely motivation, especially for like the James Webb Space Telescope, to do everything that they possibly can to ensure that this thing is going to, you know, actually work.
No, it's like kind of a bit crazy, but it's true. But solid state is about to become a popular thing for longer life.
Oh yeah, yeah. You know, I mean, if you can, you know, get away from moving parts, yeah, you know, they aren't going to wear out, right? They're just going to do their thing. Yeah, I think it's great, and yeah, I'll have to look into that a little bit too, see if I can understand a little bit. It's you know, the physics of solids is an extremely complicated thing. I actually have a couple of books. Um, let's see. Not, let's see if I can find them both. I can see one. Might be able to find the other one too. Let me see if I can grab these. Hold on. don't really want to digress into this too much, but so this one, well, this one is something I picked up, and got to admit, some books I pick up and I really haven't examined this one as much as I should, but that's a pretty good one, gotta say. And it's just a Dover book, right? I mean, it's just Dover Publications, and but it gets into the nitty gritty of solids. The classification of solid types, crystals, simple solids, semiconductors and metals, quantum mechanics, molecular binding, just on and on and on and on and on. There's tons and tons here. And then this one isn't exactly, I guess, about solids, but it deals with a lot of kinds of topics, and it's I don't know if there's here, fundamentals of statistical and thermal physics. It's the name of that dude. And again, this has a lot to do with solids. But of course, gets into lots of other things too. So yeah, it's so having a solid state gyro sounds like a good idea to me. Scott Manley did a video a couple of months ago about a recent theory about why we had so many reaction wheels failing, and pointed out our more recent probes will be immune. Okay, cool. All right, well, as I said, I think I wanted to keep this live stream a little short today, so let's just dive right in and do a object of the day. And let's pick one from the Messier catalog. Charles Messier's catalog of 110 objects that aren't comets. So I'm going to share my screen. We'll go to infinity here. And let's go over to random.org and have this wonderful site pick for us our Messier object of the day. So, of course, there's 110 of them. So here we go. Bam. M40. All right. Let's take a look here. Add. One of the great astronomical databases. And M40. Yeah, that's what I thought. M40 is one of those funky Messier objects. So let's dive in and see what happens here. Let's see. Oh, wow. Yeah. Not a lot of excitement there. Let's go over to Wikipedia, too, just for fun. Here, 40. Yeah. So M40 is one of those funny Messier objects that isn't a non-stellar object. So most of the Messier objects, most of the New General Catalog objects, all of those are anything that's not a star, right? So a galaxy or a cluster or a nebula. But in this case, M40 is is sort of a double star, right? It's just, and I don't even know if these two stars are like associated with one another. It might just be a line of sight thing. But Mr. Messier, you know, catalog this object anyway, saying, you know, this isn't a comet, doesn't seem to move. At least to him, it must have looked, you know, fuzzy, you know, because that's what he was sort of after. And actually, I'm looking right down here, and there's a paper. Let's go look at it, actually. Gaia shows that Messier 40 is definitely not a binary star. Boo hoo hoo. So it's nothing. It's just a couple of stars. Well, that's not nothing, but yeah, since it's just a pair of stars. The other Messier object that sort of comes to mind is M73, I believe, which again is just a few stars, and that's it. Just you know, it's
When is this paper published?
this is pretty recent. This is I think I saw. Well, let's go back. Let's see. It was submitted on the 2nd of December 2016. So yeah, I mean, it was published the end of 2016. So almost a couple years ago now. Yeah. So let's take a look here. Since it's just a pair of stars rather than a nebulous object. Because Charles Messier was following up on an observation of a nebulous binary star in this vicinity. So he identified no nebulosity, but he added it to his catalog for completeness. All right. Interesting. Here, I'm going to zoom in a little bit so you see that a little bit better. Okay, so that's kind of interesting that the identification was then lost until 1966. Huh. All right, let's. Oh, and that's it. That's it. So they're just saying here, right, at the first data release of Gaia, puts one star at a parallax of 2.87 milliarc seconds and the other at 7.113, right? So this one, the second one, is definitely much closer. And in fact, here you go, right? 350 parsecs and 140 parsecs. So, yep, Messier 40 comprises a pair of entirely unrelated stars. Well, boo-hoo-hoo.
But not a comet, so that's the important thing.
That is the important thing. We can be very, very certain that this is not a comet. So don't bother. Just don't bother, because it's not a comet. Okay, cool. Let's see if there's anything else here. Okay, this is just... Yeah, okay, so that's just that. Let's see, here is from 2002, a paper entitled The Nature of the Double Star M40. Let's see if we can pull up this dude here. Full referee journal article, good. Let's see, so WNC4, which is another name for this guy. Does he have? Okay, yeah. So it's known as Well, a couple of things, right? Um, is listed as a double star. Um, okay, so they are using Tycho 2 data. So the new parallax and proper motion data failed to support any assumption that the two stars in the pair are gravitationally connected. So yeah, even back then, it's sort of like, it doesn't look like they are. Yeah. So there you go. Okay. All right. Well, gee, not much here. That sort of goes well with a short
That's a bummer.
tonight. Well, it's you know, not to necessarily knock these stars, because they are stars and therefore are worthy of study. There's a nice barred spiral galaxy right next to him. Maybe that's what he saw. Who knows? I doubt it. Let's see, but yeah, it's sort of a nondescript, sort of a visual binary, just out in the middle of nowhere there, next to a pretty bright galaxy. Don't know.
So it's kind of like a bit that like our space telescope will never capture M40, huh?
Well, it's pretty unlikely. Pretty unlikely. There were eight references. Let's let's see what they have to say here. Messier 101. See, it's like, why? Yeah, I'm not quite sure why that's there. This is the one that we just looked at. So yeah, it's kind of interesting that you notice that the 2016 paper isn't on this list. Okay, yeah, nothing much there at all. Do we even know like spectral types or anything? No. I think let's go back to this paper and let's see if we can get the names of these stars again. Let's do a search for this and see if there's anything more interesting. There's a query. Because, on Astronomy Daily Live, we're pretty stubborn about things. So here we go. So here's some moderately useful information about at least the individual stars. So you can see which one that is. And let's see, it looks like it's moving towards us at about 37 kilometers per second. And at least in the visual, it's about a 9th or 10th magnitude star. Okay. Spectral type G0. So, yeah, that's pretty close to the spectral type of our sun. I think our sun is is it G2 or G5? I think it's G2.
I think it's 2, yeah.
Yeah. So that's sort of similar to our sun. That's kind of cool. Bunch of different names, of course.
It's kind of like a bit crazy. I was reading my emails, and they were talking about the solar report and like how the geomag is very quiet. And they said if the K goes at 10 or the A goes higher than 400, it's just the end of the world.
Well, that is absolutely true. We're lucky that we're not situated next to like a flare star. Yeah, our sun is at at least right now is in a very benign state, and well, I don't know about you, but I sort of like it that way. Makes it easy to observe. So okay, well, not much there either. Just a couple of references. No spectroscopy, no nothing. Wow. See if we can do it this
Wow,
way here.
that's crazy.
Well, there are lots of stars to study. So to choose this one amongst all the other ones, why choose it, right? I mean, it's just one of billions. But
Well, you chose it tonight as a random act of science, so
that's it.
you.
That's it. Exactly. Actually, here's some pretty interesting
Just
info, right?
out of the blue.
Out of the blue. So here's the temperature. It's almost 5,000 degrees. At least.
Kelvin?
Those are usually in Kelvin, yeah. A couple of measurements of parallax here. Looks like they're both probably from Gaia. Probably. Proper motions. Pretty nice. Yeah, so, we and it are sort of moving towards each other at the moment, so that's pretty cool. Let's look at the other one. That one is this guy. HD 238108. Let's see here. Search for that guy. So Sinbad is calling this a high proper motion star. I didn't look and see what the other one was, but let's see. This is moving towards the west at almost 30 milliarc seconds per year, and moving north at over one arc minute per year. So wow, that is actually, oh, I'm sorry, milliarc seconds. So that's 66 milliarc seconds. Yeah, that's not even close to 1 arc minute. Sorry. Still, that's a pretty good mover. It's a pretty good mover, and it looks like, yeah, that is from Gaia. Let's I sort of want to go back and look at the other one to see what the proper motion of that guy is. We can do that, can't we? We can do anything we want.
And there's Ray L and Altawada in the chat.
Well, hey there, Ray L and Atta.
Altawada.
Nice to see you in the chat. We're looking at Messier 40, which is one of those non-objects. Okay, so
I was trying to let you know that Altawada's also there as well.
Cool, thank you. So it actually looks like in right ascension, this other star is actually moving faster, but in declination, it's actually moving south, but pretty slowly, right? 6.6 milliarc seconds per year. That's 1,000th of 1 arc second per year. So that's not a lot of motion. What you can sort of do here is add these up in what's called quadrature, where you square each So 47.242 squared plus 6.65 squared. And then that sum, you take the square root of that, and you sort of get the overall motion. So this is saying like negative 47.7 milliarc seconds per year. So yeah, not moving incredibly fast. The other one, 238108, was that him? Yeah. So this guy is what, 28.291 squared plus 66.776 squared. And then the square root of that sum, 72.5. So yeah, so this guy is moving about 3 times faster than this guy, at least from our point of view. And which one?
Now, are you more of like just a physical calculator person, or you're more of a software calculator person?
Oh, I can be both. Yeah, I like the stuff, and I like the stuff that runs it. So I like it all. So there's the parallax. I don't remember which one was closer and which one was further away. Okay, it looks like the first one. So this guy over here, let's we'll move him. Yeah. So this guy over here is further away. I think he was at 350 parsecs. And then this guy, which looks a lot bluer, right? You see how this is sort of a yellowish tinge to it. This sort of has a bluish tinge to it. Kind of neat. And yeah, it's an F8. And an F8 is a little bit hotter than our sun. Yeah. So it's going to be a little on the bluish side. Neat. Let's see. And also, this guy, as you recall, was moving towards us. This guy is moving away from us. Kind of neat. It's got a bunch of different names, but look, only one reference. Sad. Nobody cares about the stars that make up M40 except for us. We're the only ones that care, and nobody's looking at it. It's a real bummer. All right, well, somebody needs to get on that. Let's see, so 145 parsecs is what they're saying. That's what Gaia data release 2 is saying. Nice. And pretty good agreement here with proper motions and parallaxes and all that kind of stuff. So that's kind of nice. Kind of nice. So, yeah, Messier 40, when you do the marathon, right, this is one of the objects that you have to observe and look at and or find. And so, yeah, it's, well, just look for the faint binary star. That's all it is. That's all it is. So, yeah, wow, just not very much here at all. Let's go back over to this and see if there's anything else. Yeah, not much. Just sort of the same thing over and over again. Let's, just for fun, I can be pretty sure that Hubble hasn't looked at it, but hey, we're risk takers here, you know. Nope. Didn't think so. Didn't think so. All right. Well, you know, I think that does really, really well for sort of a shortened um, live stream tonight, looking at a Messier object that you know is definitely on the more unusual side, not being, you know, sort of a fuzzy object of sorts. So that's pretty cool, though. Get out and take a look at M40. I think it said that the right ascension was around like 12 and a half hours and a declination of like plus 58. So what? That puts it, well, that puts it north of Virgo. Ursa Major, somewhere around there. Does that sound about right? Yeah, so actually, yeah, this time of year in the early evening, that's a little rough. That's a little rough. So yeah, you might have to, you know, if you're willing, you know, get up a little bit early and pull your scope out and look for the binary star that isn't actually a true binary star, right? One's here, one's way back here, right? And it just so happens that they, you know, line up to us. So, but yeah, not even really a binary star, just sort of a visual binary, as they call them. Yeah. All right. Well, that is M40, the Astronomy Daily Live object of the day. So yeah, definitely not incredibly exciting, but you know, this is astronomy, and some things are pretty cool, and some things are just sort of like, well, just a couple of stars, right? So, but who knows, right? I mean, you know, living things on planets going around, those stars could be looking at our star and saying, ah, it's just a boring G2 star. Who cares, right? There's nothing around it. You know, there's nothing to look at. Who cares, right?
I know why Messier chose that.
Well, it sort of seems as though, right? I mean, from the description in that really short little paper, that he was following up on an observation from a colleague, and for completeness sake, he just sort of, you know, kept it in his catalog. So yeah, that kind of thing. I don't even think, you know, I mean, back then he probably would have definitely seen it as two distinct stars. I don't know, though. You know, there was that galaxy right next to it, so I don't know what galaxy that actually was or is. But maybe they were seeing that. It's hard to know. You know, we sort of have to get into Messier's head a little bit, and also the colleague of his, to sort of see, you know, what they were thinking at the time. Yeah, you know, that might be worth looking into a little bit. As I said, you know, that galaxy right next door looked actually pretty bright. So who knows? Who knows? Maybe that is what they sort of meant to see, but at the time of the observation, they didn't, or maybe, you know, they wrote down the coordinates wrong.
I wonder who's going to do the Cosmos of next year. That's what I want to know.
The what next year?
The Cosmos 3.
Oh, I think it's Neil deGrasse Tyson again. Yeah, I think as far as I know, that's sort of a done deal. They're just in post-production now. So yeah, I think it's him again, and yeah, we'll see. You know, I'm terribly biased when it comes to cosmos. Carl Sagan's Cosmos, it came out for me like precisely at the right age, right? I was like I think I was like 10 or 11 or 12 or so when it came out, and that is probably one of the most impressionable times in somebody's life, and just pow, it it got me good. Yeah, that was definitely the fuel I needed to put me where I am now. So very, very cool. All right, you guys. Like I said, I think I'm going to keep this a little bit short tonight because of the late start. But tomorrow, plans are to start at the usual time, 2 hours UTC. So, all right. Well, until then, I'm going to let the Earth spin one more time and move sort of. I'm trying to remember where. I think we're moving sort of towards the constellation of Scorpius. I think so, somewhere that away, and in one day it's going to be like 20 million kilometers that away. So, all right. Well, I will see you there and then. So have a great evening, a great day, and I will see you. I will see you in a little less than 23 hours. All right. See you later. Bye.
Later.